bucka. Haha. You know the deal.
The next thing we're going to talk about is an introduction to integers. And one of the first questions you're probably going to ask yourself is, what is an integer? Well, an integer is a whole number that can be greater or less than 0. So the fact is you've been working with integers ever since you started working with numbers. Right from the beginning when you first learned to count on your fingers, those are integers. Those integers, though, typically that you've been working with so far have usually been greater than 0. But as it states here, integers include values that are less than 0 as well. Well, the next question you might ask yourself is, why bother? When would we ever use values that are less than 0? Well, you can probably think of a couple of examples. One is temperature. So here in Canada we use the metric system, and in the metric system when we measure temperature we measure in degrees Celsius. At 0 degrees Celsius water freezes, and as we all know very well in Canada, it can get significantly colder than 0 degrees. So that's one example of where we'd see a value less than 0. Another example is in finance or money. If you run a business and during the course of running that business you end up losing money, that means that you earn less than $0. Whereas if you earn money, it's more than $0. So that's an example where integers could be used. Also, some bank accounts actually allow you to take out more money than you have in your account. So if you have $10 in your account and you take out $20, well, at that point you have less than $0. So these are just two examples of where values less than 0 occur in the real world. There are several others. One powerful tool that we use to help us understand how integers work is a number line. And again, typically, you've seen number lines before, but up until about grade 7, most of the time you're looking at values that are greater than 0. And when we draw a number line, the values that are greater than 0 are always to the right of 0. So to the right of 0 we have the number 1. Well, that's the first integer bigger than 0 because it's to the right of 0. Well, as we've discussed, integers also include values that are less than 0. So we can actually move to the left of 0, because as we move to the left on a number line, the values get smaller. Now we have to have a different way of showing the values that are less than 0, because if we move to the left of 0 and called that 1, it could get very confusing because we already have a 1 to the right of 0. So when we have values that are less than 0, as we all know in temperature, we call those negative values. So our number line, when we look to the left of 0, looks like this. So as we can see there, the values to the left of 0 have that little symbol in front of it, what you would normally see as a minus sign. When we're indicating the value of an integer, that minus sign is called a negative. So to the left of 0 we have our negative values, starting with -1, moving on to -2, and so on. The values to the right of 0 also do have a symbol. We usually don't put that symbol, but it's the opposite of negative, and the opposite of negative is positive. So if we don't see a symbol in front of a number, we assume it's a positive. We can always put that positive sign there and it doesn't change the value at all. Now, as we talked about before, bigger numbers are further to the right on a number line. So if we look at the value +3 and the value -4, well, we can see that the one that's furthest to the right is +3. So we would say that +3 is greater than -4, which mathematically we would write like this. That math sentence says +3 is greater than -4. If we look at the two values, say 0 and -5, we can see once again, if we're looking for the greater value, we're always looking which one is further to the right. In this case, 0 is further to the right, so 0 is greater than -5, or we could say -5 is less than 0. So as we've seen with those previous two examples, when you're comparing integers, really a powerful tool in order to do that, and we're gonna go back to a number line a fair bit when we're talking about integers, but when you're comparing them, a number line is a powerful tool to use, and when you're comparing two integers, you can either draw a number line or you can imagine a number line, and whichever value is further to the right on that number line, that's the greater value. So I mentioned before that negative values and positive values are considered to be opposite because they're on either side of 0. When we talk about integers, we can have integers that have opposite values as well. So, for example, the integer +2 does have an opposite, and its opposite is the one that's the same distance from 0, the same number of spaces from 0. So if we look at +2, it's 2 spaces from 0. Well, the only other integer that's also 2 spaces from 0 is -2. So we would say that +2 and -2 are opposites because opposite integers are the same distance from 0. So another example is +8. Well, +8 is 8 spaces from 0. The only other value that is also 8 spaces from 0 is -8. So we would say that +8 and -8 are opposites, or opposite integers. So to finish off our introduction to integers, I'm going to ask you to answer a few questions here. Question number 1, there's a few that you have to answer there, but really all you have to do is just fill in the blank with either the less than or greater than symbol. Again, remembering that the value that's further to the right on a number line is the greater one. For question number 2, just state the opposite of -7. And then question number 3 asks, if you're in an elevator and you look at the buttons, and the very top button is +5, so that's the top floor, which is 5 floors above ground level, and the very bottom button is -3, which means 3 floors below ground level. The question is, how many floors in total are there that the elevator can go to? If you're able to answer those questions, congratulations, you now have a firm understanding of an introduction to integers.